We are tracking 7 different objects. 2 of them have already performed their perihelion. The rest will do so over the course of the next few months by the end of the year. And so this is looking like it's going to be a very dynamic end to 2025.
A colossal object 200 times bigger than anything we've seen has just activated in our solar system, and it's hunting down 3I Atlas within hours of C2025. R2 SWAN's discovery on September 12, 2025. Astronomers realized this wasn't just another comet. This is a Fortress-class object pumping out 10,000 gigawatts of power, enough energy to dwarf Earth's entire power grid, and it's on a collision course with the mysterious 3I Atlas that's been exhibiting impossible behavior for months. What you're about to hear will change everything you thought you knew about what's really happening in our solar system right now. September 12th, 2025. The SOHO spacecraft's SWAN instrument detected something that made every astronomer on Earth freeze in disbelief. A massive object blazing through space, with a tail stretching 2.5 degrees across the sky. That's 5 times wider than a full moon. Within 48 hours, amateur astronomers in Australia captured images so dramatic the streak of light nearly spilled out of their camera's field of view. The International Astronomical Union rushed to make it official, designating the object C2025 R2 SWAN. But the numbers didn't make sense. At magnitude 7.4, this thing was bright enough for backyard telescopes. Most modern comet discoveries are faint, requiring powerful equipment just to glimpse. SWAN was announcing itself like a cosmic billboard, slicing through the constellation Virgo and growing brighter as it approached the sun. The astronomical community wasn't just excited, they were in disbelief. This wasn't following any precedent from recent decades. The sheer scale reminded veteran observers of Hale-Bopp or even older legendary comets from the history books. But here's where the story takes a turn that defies explanation. SWAN isn't alone. Just days before its discovery, another object, 3I Atlas, was already inbound from a completely different sector of space. While SWAN traced back through Aquarius, Atlas entered from Sagittarius. On a star map, these arrival vectors are separated by more than a quarter of the celestial sphere. Yet both objects are set to reach their closest approach to the Sun within the same 10-day window. SWAN hits perihelion around October 20th at 150 million kilometers. Atlas reaches its closest point on October 17th, just 3 days earlier, at roughly 203 million kilometers. The geometry is staggering. Both objects follow steeply inclined orbits, with SWAN tilted more than 60 degrees off the ecliptic plane and Atlas nearly perpendicular to where the planets orbit. The odds of 2 such massive objects arriving from opposite corners of the sky, hitting nearly identical solar distances within days of each other. Astronomers who've spent careers tracking long-period comets call it vanishingly small. This isn't randomness. This is coordination.
And the reason why I think 3I Atlas will be the heavyweight of the bunch as it relates to the possible interaction with the sun and the promotion of solar activity is because it has been very, very active now since we first observed it way out beyond the orbit of Jupiter, which is pretty anomalous.
3I Atlas broke every rule in the book before SWAN even appeared. Early spectroscopic analysis from the Atlas Spec Lab group reported something that set off alarms throughout the scientific community. A composition dominated by nickel with virtually no iron. That runs counter to everything known about comets, which always show iron-nickel blends in their vapor signatures. The readings were so unexpected that multiple laboratories demanded the data be rechecked, triggering a calibration controversy that spilled across astronomy forums worldwide. But the anomalies didn't stop there. Instead of typical water vapor, Atlas pumped out carbon dioxide at rates 5 times higher than H2O. The 4.3 micron CO2 line dominated every spectrum, while water barely registered above background noise. Then came the behavior that changed everything. Observers tracking Atlas noticed 3 distinct acceleration pulses, each spaced about 2 weeks apart, each coinciding with sharp changes in tail color and brightness. July 29th, August 14th. Each pulse came on fast like a thruster firing, then faded. Nothing like the gradual push from solar heating. The energy calculations were mind-bending. If these accelerations were real, the power source inside Atlas would need to deliver around 10 gigawatts, the output of 10 large nuclear power plants. That's far beyond what any known natural process in a comet nucleus can generate. If Atlas is the agile scout, SWAN is the heavy artillery. The scale is almost incomprehensible. A tail stretching 2.5 degrees across the sky, brightness rivaling the greatest comets of the last century. And if the wildest estimates are even close, a core pumping out 10,000 gigawatts of energy. That's more raw power output than the entire electrical grid of planet Earth. But the numbers are just the beginning. Reflectance data shows SWAN's core scattering sunlight with a sharp metallic signature. Amateur spectroscopists argue this matches not just nickel, but a nickel-cobalt blend, materials specifically chosen on Earth for strength and corrosion resistance. The term nickel-cobalt hull started circulating in chat rooms and late-night astronomy podcasts, fueled by the object's stubborn refusal to break apart or dim as it closed in on the sun. Then, observers noticed something even stranger, a persistent silvery halo around the nucleus, shifting in pattern and intensity. To some, it looked like a plasma envelope, an electromagnetic shield capable of deflecting solar wind and cosmic debris. That's where the nickname Fortress comes from. Unlike Atlas with its quick, agile maneuvers, SWAN presents as an armored tank, slow, steady, and seemingly invulnerable. Photometric analysis reveals tiny rhythmic changes in tail direction, as if the object is making precision course corrections with controlled plasma bursts. SWAN's orbital period adds another layer of impossibility to this story. The calculations show a cycle of 22,554 years, meaning its last visit to the inner solar system occurred during the height of the last ice age, when glaciers covered much of the northern hemisphere and human civilization was just beginning to emerge. If this object is engineered, it's been following a preset course for longer than recorded human history, and yet it arrives now at the exact same time as Atlas, during a cosmic alignment that astronomers call statistically impossible. Some researchers have pointed to intriguing connections with ancient sites like Göbekli Tepe in Turkey. Built over 11,000 years ago, the stone pillars there contain carvings that a handful of theorists argue could represent astronomical cycles, possibly even marking the return of objects like SWAN. Whether these connections are real or coincidental remains hotly debated, but the timing raises profound questions about what our ancestors might have witnessed in the skies during SWAN's last passage. When two massive objects with these power signatures arrive in near-perfect synchronization, the conversation shifts from "what are they?" to "what are they doing here?" The most straightforward theory involves maintenance, a cosmic pit stop. Both objects could be engineered to use solar energy or magnetic fields for recharging, data exchange, or systems diagnostics. In deep space mission planning, solar flybys are standard for gravitational assists and energy collection. A darker possibility suggests intervention, a rendezvous to recover or neutralize a malfunctioning unit, or perhaps a contest between rival systems converging on a critical resource. The power levels estimated for each object certainly suggest energy reserves needed for active maneuvering, not passive drifting. There's also the escalation scenario, Oumuamua in 2017, followed by Atlas, now SWAN, each arrival representing increasingly complex responses to Earth's century of radio transmissions. Each new visitor would be a more sophisticated probe sent to gather data or establish contact. In all these frameworks, the sun isn't just a backdrop. It's the power node, the rendezvous point, the beacon that's drawing these objects together for purposes we can barely imagine. From October 8th to 18th, every major ground-based observatory faced a hard stop. Official schedules listed the window as routine solar conjunction downtime, but internal documents tell a different story. Memos from US Space Command and the European Space Agency directed teams to suspend all radar and high-resolution imaging of both SWAN and Atlas during the blackout period. Proposals for alternative coverage were denied without explanation. Requests for raw data were quietly rerouted or delayed. Telescope allocation reviewers, speaking off the record, described explicit orders to avoid public statements about either object until after perihelion passage. The result was enforced silence at the exact moment when the two most unusual visitors in decades would be crossing through the sun's glare. When official channels went dark, the amateur astronomy community stepped up. Bill Gray, known for open-source orbit calculations, rallied a distributed network of backyard observers. The Able Tracker Collective in Spain and Portugal began pooling wide-field sensor feeds, while private astronomy groups developed plans to bypass the blackout using radio telescopes and repurposed weather satellites. With government agencies off-limits and major observatories locked down, the grassroots effort became humanity's only source of real-time information about what was really happening during those crucial days. Both objects have now passed their closest approach to the Sun and are beginning their outbound journey, but the questions they've raised about the nature of our cosmic neighborhood aren't going away. The synchronized arrival, the impossible timing, the advanced propulsion signatures, and the government blackout have fundamentally changed how we think about what might be operating in the space around us. Whether these objects represent natural phenomena we don't yet understand, or something far more deliberate, the implications reach beyond astronomy into the realm of human destiny itself. SWAN, with its fortress-like properties and 22,554-year orbit, suggests a level of long-term planning that spans geological ages. Atlas, with its precise maneuvers and engineered composition, hints at technologies operating by principles we're only beginning to glimpse. Next few months will be critical as both objects move away from the Sun and into positions where Earth-based telescopes can observe them clearly. Every spectrum, every brightness measurement, every subtle course change will be analyzed for clues about their true nature and purpose. What do you think is really happening out there? Are we witnessing the greatest astronomical coincidence in human history? Or have we just caught our first clear glimpse of something that's been watching us all along? Let me know your thoughts in the comments below, and if you want to stay updated on this developing story, make sure to subscribe and hit that notification bell. This is just the beginning of what might be the most important discovery of our lifetime.